Today we're going to be covering an electromechanical workflow. Being able to have just a 3D viewer of your circuit boards, for a while there was a very big demand for that, but it only gave you a viewer. When we were actually joined from Autodesk, we wanted to take it to the next level. What we really wanted to do is actually provide you an electromechanical workflow. A workflow that would allow you to work with your circuit board and work with a mechanical application that would be useful. Useful enough in which you would actually see your circuit board in 3D, create an enclosure, be able to move components in the mechanical application, bring it back into Eagle, make the correct adjustments, push it back to the mechanical application, make any other modifications such as the enclosure, the components, the board outline, bring that back into Eagle and continuously work back and forth, because that is actually the true workflow that is needed for every product without the need of file conversions. And that's what we will actually want to demonstrate today. So, you know, I'm not going to go any further with any other slides, because that's a little bit time consuming, and I want Jorge to be able to really go over that workflow. And I want to go through a Q&A at the end of this as well to take care of any questions that you may have. So I'm just going to go ahead and pass this on over to Jorge. That way he could go over this. You ready, Jorge?
So right now we're looking at Fusion 360. Like Ed was mentioning, this is a completely bi-directional workflow. So you can start in Eagle, go to Fusion, start in Fusion, go to Eagle. Fusion 360, because it is a mechanical modeling software, has the ability to use certain sketching tools that Eagle does not have. So for example, when making, very complex board shapes, it does pay to start in Fusion 360 and use those tools. You also find that after a little while you get used to very quickly how it works. Fusion 360 is a very intuitive tool, so we definitely want to kind of explore that. So let's start. We're going to make a board outline here in Fusion 360, and then we're going to bring that into Eagle, make some changes, push it back, and then even within Fusion we can do some other things as time allows. So first thing we want to do is we want to start with the sketch. Okay, we want to define where we want to start, and we want to start in the XY. Okay, and the way you can tell is if you look at the cube on the far right over here, you see that Y is the green line, X is red, Z is blue. Okay, so we're going to go ahead and click here, and we're going to start our sketch. Whenever you're defining a board outline, you always start with a sketch. Okay, it's very important. So one thing that maybe those of you, well, we'll talk about it now when we get to it, just so that you guys know. So we have started a sketch. I'm going to start just with a basic 2-point rectangle. Okay, and I can put in a size there, let's say 50 millimeters, then tab to the other side, and let's say 65 millimeters, hit enter. Okay, and now there we have our rectangle. Okay, that's going to form the basis for our board shape. Now we can add additional things. So for example, we can sketch a little, using the circle command, we can sketch in a little hole. Let's use a center and diameter circle. We have obviously different options that we can use. Let's go ahead and draw one here. Again, you can specify whatever size you want. Okay. And let's put in a little fillet just to give it something else. So you go to fillet, select this one. Now we put it in the size for that fillet. Say 12.5, hit enter. Okay, and something that's cool here that we want to be able to keep in mind is that you can dimension things, and Fusion will basically solve to maintain the dimensions to be true. So if I go over here and I start changing dimensions or start adjusting things, all of that will allow me to change the size of this board. So let's start here. You can see that you also have these constraints. These constraints again allow, when you're adjusting the dimensions, to be able to keep the shape. So for example, if I make this longer, because there's tangential constraints here, that curve will stay in the same place even if this gets longer. So things like that. It takes a little bit of getting used to, but you'll find that it works very well. So let's say here I make it 75, and I hit enter. You'll see it extend, but because there's these tangent dimensions, everything else stays the same. So that's something that's very powerful. Setting up these constraints will allow you to scale the drawing and have the board follow it. So right now I'm happy with this shape. We'll start there, and I'll put stop sketch. Okay, so now what we want to do is we want to make a PCB out of this sketch. So one thing that we had to do in the past is go to our user preferences and then change or activate the create a PCB functionality. But that's already been incorporated into the main Fusion 360 releases, so you no longer have to do that. It's automatically going to be available. You just click create PCB. It's going to want you to select a face. So I'm going to select this one here. Okay. And then what we're going to do, seems like the little screen has gotten, bear with me 1 second. Ed?
Yes.
Your breathing is coming through. Okay, cool. I'm going to go ahead and close this over here. Okay, so I get that. Ah, there we go. That's what I wanted to see. PCB profile, I select it. Now I can specify an origin. Am I still muted?
No, you're not muted.
Okay, cool. Just gotta make sure. Okay, so this part of selecting the origin is extremely important. Wherever you select this origin, that's going to be the reference point for the board in Eagle. So a situation that cropped up recently is that someone in Fusion centered the board around the origin in Fusion, which makes sense because if you have a circular board, it makes everything easier to have the board centered. But then they picked the center of the PCB to be that same origin, and they had a size limited version of Eagle. So in doing that, they lost 3/4 of the board as work area because of the size limit version. So what you want to do is you want to select the origin in such a way that the bottom left corner of the work area is the origin here. So in this case, we can pick that origin. You see the point there, highlight. I'm going to select that. I'm going to say OK. And now we have our PCB. Okay, very nice. Make sure this is visible. For some reason it's not. That's okay though. Okay, so now we have the PCB ready. I'm going to click Finish PCB. So now what we're going to do is we're going to go to Eagle and we're going to pull this in. But before we do that, we have to save. I'm going to call this live demo. Today's date. Let's do that. Date of the 29th, right? Click save. Okay, and we have version 1. So now we're going to go to Eagle. Now in Eagle, we're going to go ahead and create a new project. So I'm going to go over here, right click, new project. Let me not put in the dashes, the forward slashes, that will create problems. Okay, so now new schematic. And I'll create a board from that schematic. Okay. Now when you create a new board, you'll see that it will give you a default board shape. In our case, we're obviously going to change that to the shape we've made. So the first thing I want to do is I'm going to go ahead and save this design. Save. Call it demo 08/28/2018. Save. And now we click on the Fusion 360 button. Okay, we can link to an existing Fusion 360 design. So click Next. Now, keep in mind that the glue that ties all of this together is your Autodesk account. So whatever Autodesk account you've logged into Fusion 360 with, that's the same one you have to use in Eagle. Okay? As you can see, it's automatically picking up the projects that I have in Fusion 360. So I'm going to click Webinar Demos. And now I have our demo here. I put that wrong. I should rename that. I'll say OK. Now what we do is we pull from Fusion, and we'll see that the outline is going to change.
Now, in this workflow that I already brought it in, what Jorge is doing is actually he's creating the board outline in Fusion 360, and the benefit of actually creating the board outline in Fusion 360 is that it has a lot more sketching tools that Eagle would ever have when it comes to actually creating complex board outlines. If you're an experienced Eagle user, you know what that means. So creating the board outline in Eagle, in Fusion 360, and being able to import it into Eagle is just one of the workflows that you could do. You know, so just want to let you know that it could actually go the other way as well. Just wanted to bring that up real quick.
Correct. So like we were saying, you can start in either one. So right now we're in Eagle, okay, and we still haven't placed any components, but just to show the forward and back, I'm going to make a change here. I'm going to use I'm going to use a miter tool, put in a radius. I don't know. Let's put in 254 mils.
So yeah, you're not tied to that outline in Fusion and bring it into Eagle. You're not really tied to it. You know, it's just easier to do it in Fusion, but you know, you're not tied to it. So just want to make sure that you understand that it's just a benefit.
Yeah. So here I made this little change. Now I go Fusion, and I can push it to Fusion. Say you type in a description. You should always type descriptions of your changes. Added small fillets on the bottom right side. And 254 mils comes out to be, I don't know what it comes out to be in metric. I think I picked a bad size there, but anyway.
Now,
I think I did it backwards.
Now, let me also add to this. Sorry, I keep on interrupting you.
Go.
Now, but I want to add also that in Fusion, if you, I want to do this because a lot of our guys I see here are Eagle guys, so they don't know this. But in Fusion, you could collaborate on projects. So let's say, for example, John, one of our users here, was using Fusion. I could collaborate Fusion projects with him. So he could have a Fusion project, and I could actually push from Eagle to a Fusion project that he's working on. So it's kind of nice that I could push from an Eagle project to John's Fusion project. You understand what I'm trying to say, George?
Yeah, because in Fusion, and this is coming to Eagle also, at least in the libraries, but in Fusion you can have people collaborate with you on a project.
Correct.
So if someone invites you in Fusion to collaborate, the same way that we saw under my account all of my projects showed up, well, when someone invites you to collaborate, that project will show up in that list and you'll be able to push to that project. So that's something that's going to be really handy when working as a team. And again, some of that is coming to Eagle's collaboration when it comes to libraries, at least initially.
So us as electrical engineers can collaborate with mechanical engineers then.
Correct.
Okay.
So now we're back to Fusion, and we see over here that Fusion has already detected the push. We see data in this folder has been updated. We click refresh. Okay, and one thing we want to keep in mind here is that the file doesn't automatically show the new version, and this is one I was working with before. So if we go over here, here's the new version. Now one thing that's cool is if we see this V2 is selectable, if you click it, it will show you the list of all the changes made, and you can see that little description that I made there, added small fillet on the bottom right edge, bottom right side. So if anything ever went wrong, you have this entire history of the board's creation, and you can go back to any version. You can switch back to a previous version should anything go horribly wrong, which we know never happens, right, Ed?
Never.
So let's go ahead and open this one up, and now we'll see that there's the little fillet edge. Okay, so now in Eagle, if we go back, we see that it can go backwards and forwards. Let's start putting in some components to this file. Okay, so let's go over to Eagle. Let's start putting some parts on this. You can go over here. I think I have a design block already ready. Yes, I do. Cool. Okay, I bring in the schematic part. Now for those of you who don't know, design blocks are basically reusable circuit segments. So you have both a schematic part and you have the layout. So it comes in really handy for, you know, circuitry that you use often depending on what your line of work is. Many designs maybe start with certain fundamental things, like in audio for example. Bypass circuitry is usually the same on all the models that a manufacturer makes. So that may become a design block that they can just reuse from design to design. Now I want to take advantage and actually show you a pretty cool feature, and that is the polygonize command. So right now we have the outline of this board. If I right click on the outline, you're going to see in the context menu there's this new option called convert to polygon. You have a copy, which basically creates a polygon that is a copy of the outline, and you have replace, which replaces the outline with a polygon. So in my case I want copy. I'm going to pick the layer, let's say top. Okay, and if we look, you're going to see there's a polygon there. Now we can use a name command, give it a name, call it ground, and now we rat's nest, and beautiful.
Okay, I think we need to explain what you did, Jorge.
We need to explain the magic?
Yeah, I think you should explain how you took that enclosure, copied it, and turned that into a polygon real quick.
Real quick? I did.
Yeah,
I said polygonize command. It's magic.
Yeah.
It's awesome.
Yeah, I think you need to explain that real quick. Yeah.
Okay. So let me go ahead and rip this up.
Yeah, please.
So basically what you do is on the outline itself, you can right click. And actually let me turn off the top layer just so I can repeat, and then I'll leave the top layer on again so we can, or I'll just switch the dimension to make it the selection layer. Okay, if I right click on it, okay, so it's not affecting that selection, so I do have to turn it off. Say okay. Alright, so if I right click on the outline, on any closed outline, just to clarify, any closed outline, doesn't just have to be on dimension. If I right click, there's this option convert to polygon, and I have the option to copy the outline to a polygon and leave the original outline alone, or I have the option to replace the original outline with a new polygon. Okay, so that allows you to follow perfectly the contour of the board. So if I pick copy, I select what layer I want it to be on. I can say bottom in this case, and if we look now, we have a polygon there, and I can use the name command, go there, name it ground, and there we go. And again, I can do a rat's nest, and it will connect to where it's supposed to. Okay, so hopefully that makes sense.
Yeah, now it did. Now that was slow enough for all of us to get
Okay.
that.
Now, the inverse is also possible. So I'm going to go ahead and, just as an example, right click. Bottom is now the preferred selection, so it'll go to the polygon. And you'll see there's an option to convert it to wires. So you can go both ways. You can convert wires, a close contour of wires, to polygons, or you can convert the polygon back to wires. So you can go in both directions.
Excellent.
Very handy feature. So now what I'm going to do is I'm going to go back here and turn on the top as well, There we go. Now we have both. Okay, so these components already have 3D models assigned. So that's going to make the next part a lot easier. So if I do an info on these, what you're going to see that these are all components that should be in a managed library, if memory serves. I may be wrong. If not, what I can do is I can do an update. And in fact, that's probably what I should do. Push to Fusion, yeah. Yeah, these are also using the original unmanaged version. So I'm going to push it just so you guys can see what happens when you don't have managed library, and then I'll do the library update. So first push. Any questions so far that I should stop?
It's okay. Hey, John, I have an answer for your question. I'll take care of it towards the end, but I do have an answer for you. It's just that he has holes on his board and it's getting that little gray block. I just have to tell him how to take care of that, and
Right.
there's an answer for that. I'll take care of it at the end.
Okay, cool. So let's go ahead and push this.
So while that's pushing, John, what you do is that when you assign 3D models in the library editor, what you're going to do is that in the package editor for that model, what you're going to do is that you're going to give it a size of 0 for the X, Y, and Z for those test points, and that way you don't get the gray 3D block. That's what you're going to do, just to let you know.
Yep. So that's the way to do it in the library. It's basically a workaround for telling Fusion that, hey, I don't want a model on this. There's one other thing you could do about it. It all depends on how obsessive you want to be about it. So again, Fusion sees that something's been updated at refresh, and there we see 23 seconds ago, first push. Let's go ahead and open up now version 3 of the board. And there we go. So notice that if you have nothing mapped, you get these rectangles. Okay? That is the default safe 3D model. Rectangles of 1 millimeter height. Okay? Now, just to go back to John's question, let's say this connector here wasn't supposed to have a model. You know, it was just supposed to be the exposed pads. Another thing you could do, just turn it off. That works too.
That's good.
Yeah, if that makes you happy.
Yeah,
but
that looks
again,
good. Mm-hmm.
You know, it depends on how obsessive someone wants to be about it. But yeah, you have full control over their visibility and you can turn them off. So now let's go back to Eagle and let's replace these parts with parts that do have 3D models. A lot of the parts that ship with Eagle now do carry 3D models. So in this case, a simple library update is going to fix all of this. So I'm going to go library. I'm going to do an update all. Library update has modified the board. Please run a design rules check. Okay. And now if I do an info, we're going to see that it's using managed libraries. Whenever you see version numbers, those are managed libraries. Those are the ones that are going to have 3D models assigned. And I can check that with all of them.
Later in September, we're going to have a webinar about managed libraries as well, okay? So keep track of those.
Yeah, because if not, this will become a 3-hour webinar.
Yeah, exactly. Mm-hmm.
And even then, I don't know if we'd cover everything.
Exactly. A whole day webinar.
So now, we can push to Fusion because we've updated the libraries that contain 3D models. And you'll see check marks on everything. Updated to managed libraries. Again, always write version descriptions. For some people it may seem like just a waste of time, but if something goes wrong, you want to know where it went wrong, and this can help you. So I push. Okay, we'll give it a few seconds. Now we go back to Fusion. Fusion detects it. We refresh it. 4 seconds ago. Close it. Don't save. And there we are. Okay. So very nice. Now we have everything here. Now keep in mind, you can move components around. You can make certain changes. So it's stuff that the mechanical engineer would be interested in. If you do make a mechanical change here, the traces won't automatically update, won't automatically fix. So when they get pulled into Eagle, the electrical engineer will have to fix it. So just to play with that a little bit, I'm going to go front view. I'm going to right click here at the bottom on what Fusion calls the timeline. I can say edit, and we have this option of move PCB components. So I select it, I select the component. You'll see that you get these arrows. I can rotate. I can, move them as I please. Okay, so let's say something like that, some very simple move, which here doesn't appear too crazy, but will actually reflect an Eagle because the trace will kind of bend in a weird angle. So we'll say OK. And there we go. See, it doesn't automatically update. So let's go ahead and finish the PCB. Again, I'll save it. Now we put a description. Moved JP2. Okay, we saved it. Now when we go to Eagle, Eagle's going to see that something changed. And again, you can see the versions are updating. You have all of that information. You have that crumb trail that you can follow from the beginning all the way up to the current point. Whoops. So we go over here to the board. Okay, and Eagle has detected that change. We pull from Fusion. We accept it. JP2. Okay, we see that the traces have now kind of been relocated. We can do a rat's nest to fix that, to fix at least the polygon pore. But now we got to fix the traces. Okay, and there's a few ways to do that are nice. So first way.
Those traces look just fine. What's wrong?
I don't like that little weird angle there. No. Maybe nobody else cares, but I do. So, and it's a good excuse to show off features, so doing that. So loop removal is on, easiest way to fix it. You start to trace over here, and I have it in the curve. I think I have control held down or something. Width, let's put it at 12. Oh, I know why, because I have a radius here. That's why. There we go. Okay, so notice that when you do that, loop remove automatically gets rid of the old one. I definitely want to increase the size of this. So let's say, I don't know, 16. 16 was too big. 12, 10. 10 looks right. Right, Ed?
Yeah, sounds about right, yeah.
Okay, cool. And then we'll go over here. Again, 10. Now we can fix it by doing that. There we are.
Why don't you just quick route it?
It's another option. We're trying to show everything, so yeah, that's a good idea. So I'll rip this up over here. Say connected copper. Got all that. I think that's that's a power rail. Alright, it's okay. So we'll go to quick route. Quick route signal. It went around a different way.
Yeah, it took another route.
Yeah, it worked though, so I'm not going to complain. And now we do the rat's nest. Now it's happy. And now we'll go ahead and push this to Fusion 360. Keep in mind, active layer changes the rendering order, so always keep that in mind. If something looks odd to you, just mess with the rendering order and you'll get what you get it to look the way you want. So Fusion 360, push it to Fusion, fix the routing, and we push.
You know, one of the nice features also, I wanted to bring it up on this webinar is, you know, on the manufacturing flyway menu, you could change the colors of like the solder mask layers now, and Fusion 360 now sees that as well. So you don't always have to go with a green.
That's
green board
right.
if you want to. You don't always have to go with a green board.
Let's go ahead and show that. Manufacturing. You go here to the settings. Configure preview. It is a solder mask color. Right now it's green. Pick a color, Ed.
Go with yellow, man. I like yellow.
Yellow board?
Yeah.
Alright, let's make it yellow. Oh, it's gonna hurt my eyeballs. Ooh, man. I shouldn't have let you pick. Alright, push to Fusion. Change solder mask to yellow. Push.
You know, this gives you a realistic view. Also, I've seen some users actually take advantage of this for documentation purposes. I see they're using it for their manuals and
Yeah, you get the screenshot of it.
yeah, for their screenshots for their documentation.
And we can do some LASIK with the brightness of the yellow. Ugh, you had to pick yellow, Ed. Okay, and there we are. There's our yellow PCB.
I should have gone something with like a purple maybe.
Purple, yeah, purple would have been realistic for Osh Park.
Go with make our Osh Park friends happy.
Okay, so this is basically the workflow. You can see it's back and forth. We can move components around. We can change traces. We can do the mapping. I think we should leave it here, Ed. What do you think?
Yeah, that's not a bad idea. We could leave it here this time around, even though the last time we actually built an enclosure around it the last time. But I think we should do that the next time on later this month in September, Jorge, because it went a little overboard. But you know, we wanted just to show you the first workflow, which is basically creating an outline and holes in Fusion 360 and see how that actually reacts in Eagle, and then making modifications in Eagle and push that back into Fusion, and then populate the board, push that to Fusion, and then move components in Fusion, bring that back into Eagle, see how it works in Eagle, and then push that back into Fusion 360. So we just wanted to demonstrate that from the standpoint of the electrical engineer. That way you could see how that workflow actually and works. And then later on, we're gonna our next one, we're gonna go with an enclosure. And what I really want to do is on our next one, we're gonna take an existing enclosure and create a board outline from an existing enclosure. So we're going to actually project an enclosure and create that outline, and then take that projected outline and bring that into Eagle and populate that. And we'll do that on our next webinar, which is going to be sometime towards the end of September. That I should be back from some other presentations. That sounds good, Jorge, with you?
Sounds good.
Excellent. Do we have any other questions that anybody would like us to cover or review from the materials that we've covered so far? In the meantime, I'm going to be adding some links about the bundles that we currently are offering, okay, in the meantime. So Jorge, could you take a look at the chats and on the Q&A in the meantime?
Yes, sir. Taking a look right now. So far, doesn't seem like we're missing anything. If there's any question we haven't answered, guys, just go ahead and Any questions? Anything? I'm not seeing anything. Do you see anything on your chat? Sometimes it goes straight to host or...
No, not yet. I don't see anything. No, not yet. Other than Rick making some funny comments about our yellow boards.
I make funny comments too. I don't blame you.
You should go back to Eagle, put some purple boards in case we have any of our Osh Parks friends here, just in case.
Let's leave it yellow because everybody expects purple.
Yeah,
And yeah,
okay.
it burns my eyeballs, but let's leave it yellow.
You know, I did some screenshots for marketing on yellow, and I kind of liked it a lot, actually.
It's bright and happy.
I did
That's what PCBs need to
yeah,
be.
I did a render in yellow. I thought it looked pretty cool. Okay,
Yeah, I think we're good.
everybody, thanks for joining us. Greatly appreciate it. Have a great day.